Have you observed that when you drop an egg on a hard concrete surface, it is more likely to crack open? It won't take up to 3 seconds or 5 seconds. Almost immediately, the egg will crack open. But when you drop the same egg on sand, or let's say a basket or a basin of rice, uncooked rice, the egg will not get cracked open. The egg will just land softly as though nothing happened. Why does this happen? What's the reason behind this phenomenon? That is what we are going to discuss today, which is called impulse. Now, to understand impulse, you must understand the idea of force and must understand the idea of time, because force and time are very important in the understanding of impulse. Now, take a look at this. Let me build on what we discussed before on momentum to make it easier for you to understand. Imagine this to be an object, all right? It is found at position A, and the object is about to go to position C. Let's say this is A, this is B, and of course this is C. Pay attention closely. If the object moves from this point to this point, which is position B now, while in motion, let's say while in motion, the mass is 4 kilogram, the velocity is 6 meter per second. When the object gets to this point, let's say something happened. Let's just assume that a force from this direction hit the object in such a way that the object used less time in moving from this point to this point. That means from this point to this point, the object had a velocity of 6 meters per second. But from this point to this point, the object became faster because of the force that hit the object. All right. So let's assume that the mass is still 4 kilogram. The velocity now will change from 6, let's say 8 meters per second. Now, consider this scenario and consider another scenario. There are two cases. In the first case, it moved from point A to point B to point C. The mass is 4, initial velocity is 6, final velocity is 8. Now look at the second scenario. Let's say you have this as an object that moved the same way this guy moved now from point A to point B and then to point C. All right. Let's assume the mass in this case is the same as what you had here, which is 4. Velocity is same here, which is 6. In this case, the mass now is 4 kilogram. If the force that hit this guy, let's assume the force is instantaneous, is sudden. Let's say a force of 5 Newton hit this guy for just a second. Now imagine this case. Imagine that same force of 5 Newton hit this guy, which of course is the same object anyway, but is now in a new position. That same force of 5 Newton hit this object, but it did not hit it for 1 second. It hit the object and continued pushing the object for 3 seconds. My question to you, which of these cases, the first case and second case, in which case do you think the object will get to position C? Which one will most probably get to position C? Right? I know what you are thinking. In this case, because the force is 5 Newton, but the time here is 1 second, there's a high possibility or probability that the object will begin to lose its velocity almost immediately. So maybe this force hit this guy, force of 5 Newton. Between this point B and point C, the force will be dropping. That means velocity will be dropping. So this guy might not get here, but this guy will be able to maintain his velocity for a longer time. So can therefore assume in this case now that the final velocity in this case now, velocity here will be more than the velocity here. Why is it different? Because in this case, the force of 5 Newton just moved this for 1 second. So immediately the force touched this guy, it started moving this way, reducing his speed, reducing his velocity. He might not even get to point C. But in this case, that same force of 5 Newton was able to move this guy over 3 seconds before stopping. Shoot 3 seconds, then stop. That means that by the time this guy will move from, let's say this is the object now. After 1 second, it is now here. After 2 seconds, it is here. After 3 seconds, it is here. Before the stop was removed from this object. That means when this object moves on its own now, and is now at this point here, the speed at this point will most probably be more than the speed of this object when it is here. By so doing, it now means the velocity in this case now is more, or will be more than the velocity in this case. Why? Just because the time in this case was more than the time in this case. The product of the force and time in this case, or the product of the force and time in this case, is what we call impulse. That therefore means that the value of impulse, or the force and the time which determine impulse, can also determine the rate of change of momentum. Meaning, the more the force, the more the time, the more the impulse, the more the change in momentum. If the force is less, the time is less, the change will not be so much. Yeah, it moved from A to B, but now it won't move that far because the force and time are small. But the force and time are large, it will move from here to a larger distance. Even when the forces are the same, provided that the time in this case now is more than the time in this case, the impulse here will be more than the impulse here. By so doing, there will be more change in momentum in this case than what you have in this case. So if you're asking the exam, what is impulse? You say this. The impulse on a body is the product of the force acting on the body and the time during which it acts. Alright, this is the definition for impulse. The impulse on the body is defined as the product of the force acting on the body and the time during which it acts. Now, take note of this. Product, force, and of course, time. In mathematics, whenever you hear the word product simply means multiplication, right? And now you have force and you have time. So you can come around and say force times time is equal to impulse, right? The symbolical representation of force is F. So you come around and say F, and the unit is Newton. The symbol for time is T, and the unit is second. The symbol for impulse is I. Now in this case, I don't have to use P or use M or use Q for impulse. No, because take a look at it. Force is F, time is T. Impulse should be I because F, T, and I are not the same. Unlike in the case of momentum, where we have to explain to you that the reason why we can't use M for momentum is because mass is also represented by using M. So in this case, I'll come around and say this is Newton second. This right here is the formula for impulse. Impulse equal to force times time. So I'll come around and say I is equal to Ft, and the unit is Newton second.